my favorite things to read about is the history of computing, and Uncle Bob just released a book called We Programmers that actually chronicles all the way from Babbage to present day about computing and its history. And today, Uncle Bob sat down with us and talked about the greats of computing history, from Babbage and Ada to von Neumann, Alan Turing, and even Grace Hopper. And their stories are absolutely fascinating. Today's video is sponsored by CodeRabbit, which has semantic analysis and AI-powered code review, and Sentry, the best way to track your errors. Not that I actually have any. More on both those sponsors later. And now, Uncle Bob. Well, today we have Uncle Bob, the legendary Uncle Bob, on our stream today. And I think something that makes this unique is that typically this is around, like, say, a technology that has recently come out, or you've been building something really, really neat. Whereas today we're going to be talking more about history, which is kind of, I guess, a more unusual one on this channel. So you just recently wrote a book that's kind of chronicling through really the very origins of computation all the way through modern day, from pretty much every legendary figure that is imaginable. Like, all the classic ones I learned about through college are in there and more. So it is quite the amazing story. And so, do you have, by the way, just I guess to kind of really start this off, why even start writing a book on history? Why not continue down all the technical stuff? Because that's really like what people do. You sell technical books for people who want to learn. So why do something so far outside of the traditional tech route?
It's something of a trademark of mine that at the beginning of every hour that I teach a class, I open it with a science lecture or a history lecture or something that programmers would be interested in hearing, that'll clear their brains so they can get ready for the next lecture. I also use it to get everybody to sit down and shut up after a break. And I accumulated enough material doing that I thought, there's a lot of programmers that just do not know what their roots are and what it was like in those very early days. And I think it's something that programmers would appreciate. And the problem with that is that the books that are out there that sort of do that gloss over all the technical details. And I wanted to do the opposite. I wanted to put those technical details in your face, so that if you're a programmer, you can identify with these people and the problems they were having at the time. So that was kind of the goal behind it all.
Yeah, I thought it was really interesting. You can tell from reading it, and it's like a very fun read, I do have to say. Like as you're going, that it's from the perspective of someone who has, debugged software before. But now we're imagining this like when we had mechanical levers that needed to spin or punch cards that needed to get fed into a machine. And just thinking about that and imagining the 24/7 nature of this and everyone breathing down your neck because it's, World War II or something is sort of like, oh, there's a lot going on there that really I never considered before.
It is kind of it's such a different world in the sense that when, back when both TJ and I were fully and gainfully employed, like the breathing down the neck was, hey, we have a quarter project we're going to want to get done. And also, hey, we're going to go play bocce ball later, right? Like, it's not the same feeling as like, if you don't finish this in a week, we might lose a war. You got to hustle. And the rooms are like 110
equations
degrees.
You're about to process are the equations that model the implosion of a plutonium core. Don't ask us why.
We just want to know what would happen.
It's just a math problem we're interested in that you need to solve right now or else.
We're also the government. We're definitely known for just doing fun research. Trust me. We're all having fun now. TJ did build a very beautiful roadmap for all the things we should talk about. And the very first one we should talk about is kind of, I wouldn't say it's like a passion project of mine, but it is definitely something that I feel is most slighted out of everybody, which is Charles Babbage. I feel like he just has the greatest slight against all programming because he just always gets immediately foreshadowed by the person he ultimately hired to work with him, Ada Lovelace. And so yes. I'm very happy that the book starts off here and really kind of talks about the relationship between these two and really emphasizes and shows like how amazing both of them really were.
They were both remarkable people. Babbage, if you could fault him, it's because he couldn't finish anything. And we've all known people like this, where You get halfway through the project and you lose kind of interest in it because there's a better project that you can do. And Babbage was kind of that guy over and over and over again. So he built castles in the air, and he built half the machines, sort of. And then all of the people that he had convinced to help fund him and stuff would bail out on him in the end. And he was really left with this kind of half career or half set of projects with nothing ever done, nothing ever finished. Just this trail of detritus along the way. A few little machines here, a few ideas there, some grand, beautiful ideas, but none of them ever brought to fruition. That's not to say he never finished anything. There were other things he did do. He wrote some books, and he did some other projects like that. But the big things in his life, he left half finished, or less than half finished. Very interesting guy.
Yeah, that doesn't sound like anyone we know, right, Prime?
I don't know anybody who wouldn't finish a project. Definitely not me. I can tell you that much.
I'm just wondering, was Charles Babbage a Twitch streamer or like, you know?
He was a social butterfly is what he was. So if there had been Twitch at the time, he would have been on it. But he had all the big names in Victorian England at the time. You know, he knew people like oh crap, the name who wrote the Christmas Carol?
Charles Dickens.
Charles Dickens. He knew Charles Dickens. He knew Wheatstone. He knew George Boole. He knew all these guys. He knew Michael Faraday. You know, he knew all these guys from that era, and they would all go to each other's parties. And he had mammoth blowout parties, and he would go to mammoth blowout parties. He was a social character, very successful in that. But then he had this itch, you know, to build something technical, to solve this really interesting technical problem, which I think once he had solved it in his brain, he wasn't really so interested in finishing.
I can relate heavily to that. Would you say that? Would you say that, in some sense, Charles Babbage was like the modern software engineer trying to get VCs to invest in projects? Comes up with a great idea, gets some money poured in, comes up with the next idea, gets some monies poured in.
Yeah, except that he never did do a sellout. There was no exit strategy for the guy.
No exit, just all investment.
He got a lot of money. He put a lot of his own money into it too, but he got a lot of money for the thing, and blew a decade on it. And then everybody finally abandoned it. Even his friends. It was very embarrassing. He had wrangled a whole bunch of his friends to help out with that, and then they all said, never mind. We don't actually need the machine anyway.
I do think maybe for some of the people who aren't as aware of like what the machine is, maybe we can start with a little bit of background. I knew that people, of course, before we had, TI-84s, right? People had to handwrite down calculations and everything, obviously, right? But like, what was the original problem Babbage is trying to solve? Because I had never heard it, laid out so clearly as in the book.
Imagine these two guys sitting out having a picnic, and the task that they've set before them is to validate a series of tables created by two separate teams. The two separate teams are supposed to create the same tables. The tables are tables of like 60-digit numbers. Something absurd like that. And the one guy reads a 60-digit number, and the other guy looks to make sure it's the same number, right? And then they just keep on doing that over and over for thousands of them. And at the end of it, Babbage exclaims, "I wish to God these things had been computed by steam." And that sets the thing motion. That sets the motion in his head. He was going to do it by steam. In the end, he didn't have a steam engine. He had a crank, but you get the idea. Let's mechanize this. The goal was to solve Taylor expansions. You need to know the sine of an angle. You do a Taylor expansion. Taylor expansion is just a long polynomial. Long polynomial can be solved through the method of differences, which, read the book to see a really nice example of that. Which I did in Clojure on my laptop. But you can reduce the problem to a number of additions instead of calculating each of those horrible polynomials with factorials and stuff like that. You can reduce the problem down to a bunch of additions, and that's what was on those sheets of paper that they were validating. The mathematicians had come up with the formula. They'd hand it over to hairdressers who could add. Yeah, and these hairdressers would do thousands of additions of 60-digit numbers. And then it was up to Babbage and his buddy to validate them. That was just one of the instigators of this machine of his. His machine was going to be doing all those additions. That's really all it was. It was a great big adding machine with a bunch of memory in it.
And I didn't realize how the sort of range of things that they were using, like sign calculations for. They're like, oh, we need it for like navigating in boats and like for building stuff or like for, and they're like, oh, so these, this was like a real job. People just like, and I mean, this is where was it originally with Babbage or was it later that they had this job title of computer?
The word computer in those days referred to a human.
Right. Yeah. Did it start as the job title in Babbage's time, or was that later?
Oh, that's a really good question. I don't know if they called them computers in Babbage's day. They were very low-paid, menial, manual laborers, and they used hairdressers because the French Revolution caused a lot of unemployed hairdressers. So I don't know if they called them.
Can we just back up? What do you mean the French Revolution caused a lot of unemployed hairdressers? Did it cause a lot of unemployed everybody and hairdressers were particularly good at addition, or was it specifically hairdressing that really got hit the hardest?
Let's just say that there were fewer heads.
This all makes a lot of sense all of a sudden.
I'm not joking about this.
I like that one. I'm definitely stealing that one for later.
I don't know how you're going to steal that exceptionally specific piece of knowledge for later.
I'm gonna bring it up just randomly to my wife, and then she won't get it and won't laugh. Hey, Prime.
Yeah?
Have you heard of today's sponsor, CodeRabbit?
Let me guess. It's an AI code review tool that people actually use and is good.
Yeah, that's correct.
Let me guess. CodeRabbit's being used in over 1 million repositories and has reviewed more than 5 million pull requests.
Okay, 2 in a row. That's a little weird.
Let me guess. It's not just AI, but there's tools built on top such as AST, grep, linters, and more.
Are you Steph Curry? Because you're hitting every shot.
Let me guess. It works on every major platform. It has enterprise features such as SOC 2, and it has pluggable LLMs.
Okay, are you that Turkish guy, Mr. Shooter? If you know so much about CodeRabbit, what should our listeners do?
They should click the link in the description and install CodeRabbit in their open source repos for free. But seriously, check out CodeRabbit. It's actually really good.
In the description. So I think, in this period of Babbage, I think I loved this quote from the book. So I'll just read this and then we can talk a little bit about this, I think, before we, end up talking a little bit about Ada as well. But there's something magical about the idea that by simply applying a physical force to a machine, the machine would do something that had previously belonged to the domain of thinking, which when for us, it's so commonplace, right? That I press buttons on the machine and it gets out the right numbers. We just type in these little numbers, blah, blah, and then out comes new numbers. But man, that must have been crazy for them at the time.
Well, you can. There's a good analogy here. I mean, we are currently amazed by large language models, right? These things are behaving in ways that we find startling. That was the same with them. I mean, you could add 2 numbers with a machine. What? Only humans could do that. And all of a sudden, you have a machine doing it. So it's the same thing. It's just at a different scale.
Yeah, I was about to say, during the Charles Babbage part, when he was doing the night or the parties and inviting people over, and then he showed this kind of, magical machine off, that people would say like, "Oh my gosh, the machines are thinking." Like they'd use that type of phrase, right? And so it's like there is a very strong relation between what Charles Babbage and his people during that day were experiencing. Maybe we could say that ours is different, but either way, our perception of it is fairly similar in the sense that we're looking at machines thinking in some
doing things that only humans had done before.
Yeah.
And that's really the issue. Give us a couple of years and we'll look at ChatGPT and large language models as just machines. Yeah. But, there's that moment when you think, wow, that thing did that. And then later on, it's like, okay, it's still all machines. Who cares?
that day does need remarkable.
To come soon.
It's here for some of us.
Yeah. Okay, so I want to transition kind of to Ada Lovelace as well, but I want to kind of ask more of a contentious question. What do you think is the primary reason why people attribute so much success to Ada? And it almost seems like Babbage is more of an afterthought, or like, he was there. And like, that's about it.
Well, you want my personal opinion there. There's a has been for many decades now a societal need to promote one gender over another. And that's really the motive there. All of a sudden you see, the very first programmer was a woman. Well, okay, it's not quite true. But you can understand why people would want to promote that, people with a certain agenda.
Can you kind of explain more sorry. Go on, DJ.
No,
I was going to say, I think we see pretty clearly like Babbage, and you mentioned it in your book as well, like he doesn't think of it as only manipulating numbers. So, I mean, like, it's true he never finishes anything. So, I mean, maybe he's not the first programmer to finish a project, which maybe makes him, more programmer, right? How many of us have never been?
Mark of a true programmer is to not finish anything.
It's fair. Pretty fair.
But it does seem sometimes he gets a little bit shorted in this aspect of like he only was concerned with numbers, but he was thinking of quite a few things in some level of symbolic nature, it seems.
Oh my goodness, yes. I mean, he was contemplating having these machines play chess, right? He had worked out a machine to play tic-tac-toe, noughts and crosses, right? He had worked all that out. So he was well beyond the idea that these machines were simply numerical processors. He was well into the whole symbolic idea. And there have been a number of publications out there that have credited that entirely to Ada. And that's just not fair. That is not the case. Babbage and Ada shared a lot of ideas. They were intensely communicative. They wrote letters back and forth to each other. They sent messages to each other. They met all kinds of times. They were pair programmers. They worked really closely when they could. And so any idea that one had would get cross-fertilized to the other and back and forth.
So would it be more fair, like if the record were corrected into like maybe a proper historical perspective, is that they both shared and created this idea of the symbolic nature of computing, and it's not just numbers, that they were able to co-create this idea of being able to create a machine that could actually do something more than just add two numbers?
I think they fed the idea back and forth to each other, but the original concept was Babbage's. Babbage was thinking about playing chess and playing games long before Ada got involved. Now, once Ada did get involved, there was a lot more cross-pollination. She just loved the idea. She was one of those remarkable people who has a deep insight from the barest possible evidence. She saw one of Babbage's mock-up machines, and it just kind of sprang into her brain. Like, oh my God, what could be possible here? She was completely over the moon with the idea of a machine that could follow a set of instructions, moving data from memory to processing and back to memory. She had it down. If she had been born 100 years later, she would have been a significant programmer.
Let's see. Fun fact: Ada Lovelace, right? She was very connected in the world, right? In the sense, right? Is she Lord Byron's daughter? What was her story?
Lord Byron's daughter.
Lord Byron's daughter. For those that don't know, Lord Byron influenced Shelby to write Frankenstein in his summer mansions way back, right? Like it's like a really oddly connected group of people, and she was a part of this odd connection that exists.
This was the middle-level nobility of Victorian England. He was the lord of something or other. I can't even remember what it was, but he was also a jerk. He was the word Lothario does not do him justice. He was a gambler, a drunkard. He nailed every woman he could get his hands on, including some of his relatives. He was not a great guy.
This is
he was also the author of Don Juan. Lord Byron, yeah. The author of Don Juan, the Hebrew melodies. A very, very accomplished poet and really nasty guy. And he wrangled Ada's mother to marry him. And he sired the one child, and the child was female, and that really bothered him. And through one set of quasi-rapes after another, he was finally ejected from both his home and the country, never returned to England, and never saw his baby daughter more than once or twice. And yet she wanted to be buried next to him and named her children after him. Very strange stuff going on there.
It was a confusing time, okay? You know, we like to say that the 60s were a wild time, but I think the 1860s might have been a lot more wild back then.
You know, there were definitely things going on. The story with Mary Shelley is fascinating because this was the year of a big volcanic explosion, and it was called the Year Without a Summer, right? So you had crops failing all over Europe and all over America, and freezing temperatures in July throughout most of the continents. And these guys hid out in the mansions because they were very rich. So this Mary Shelley connection was fascinating. They were all hiding out because it was cold and yucky and rainy, and they would tell ghost stories. And it was Lord Byron who challenged everybody to write a ghost story. And Mary Shelley used that opportunity to write Frankenstein, or the beginnings of Frankenstein. So we have this lovely connection from Charles Babbage all the way to Frankenstein.
And lo and behold, a summer at a villa, was gave us birth to the what's called modern sci-fi category. It's kind of wild to think about. A volcano that caused the world to be in winter caused sci-fi.
Yes.
Git commit best feature ever. Git push. Git pull rebase best feature.
Sentry can't fix this, but it can speed up slowdowns and prevent crashes with just 5 lines of code. So you can fix what really matters, even if you can't fix everything else.
I do think one of the interesting things, though, that like I wasn't aware of when I was first reading about Ada was just how much she and Babbage were talking and communicating, and some of the work she did in originally translating and then adding more stuff to his original difference in analytical machine. Could you talk a little bit about that?
Well, Babbage went on a tour at one point. He was invited to give a talk. It was the only talk he gave on the analytical engine, and he gave it in Turin, Italy. And he had extracted a promise from the conference organizer that the conference organizer would write up a document about this, but the organizer did not for 2 years, and then finally delegated it off to a young lieutenant. The young lieutenant wrote up conference notes in French, and Babbage got them, but he's like, okay, what do I do with this now? And Ada was there, and Ada knew French very well, so Ada decided to translate them into English. And while that was going on, and that was actually a gift, a surprise present between Ada and Wheatstone, who had decided to present Babbage with the translated notes. And Babbage was so impressed with the translated notes that he told Ada you're capable of writing a paper on your own. Why don't you write your own? And if you don't want to do that, well, then just add some stuff to this one. And Ada then went on to write the famous, annotations that described the analytical engine from her point of view. And boy, does she get effusive in those notes. She's like glowing and talking about all the great things that could possibly happen. Well, this, that, and the other thing. She goes over the moon over this.
So they're all just doing the VC work out there, really, is what you're trying to tell me.
I don't think they had any thought that they were going to get funding. Babbage was pretty convinced by that time that nobody was going to give him any more money. The prime minister was walking around saying, "How do I get rid of this guy? He's such a nuisance." So I think he'd blown all of his credibility by then. But they did spend a lot of time planning that machine. Babbage went deep into the design of it. It was how the gears would mesh and how things would move. And he had invented this entire dynamic notation that nobody had ever thought about before, right? Because machines usually were pretty simple. These machines were complicated. They had steps. They were actually like finite state machines. And he invented this notation that would allow him to track from moment to moment to moment to moment which gear would move and which clutch would seize and which lever would twist this way, so that he could model out the behavior of a very complex machine.
But then, unfortunately, like many other Babbage projects, he doesn't finish and spends a lot of money in the process. And it kind of lays like somewhat, I don't know, dormant in a way for quite a while. And then I think maybe the next years. Yeah, maybe the next interesting character to bring on the scene would be maybe John von Neumann. Maybe you want to give us a little intro on him and how he sort of comes into this world of computing, because it's quite a fun story how he gets started here.
John von Neumann might have been the smartest person ever born. I mean, you'd have to put that title on von Neumann or Charles or Einstein or Maxwell, somebody like that. This guy was a soaring intellect. He got involved with relativity, general relativity. He got involved with quantum mechanics in the early days. He got involved with nuclear physics and nuclear reactions. And he got involved with computing. Just a remarkable guy. And he's a refugee from Europe because he's Jewish. So, the anti-Semitic winds were blowing pretty hard, and he bailed out real fast. Got into the United States, got to Princeton, was one of the first guys to get into the Advanced Institute studies at Princeton, and then brought a whole bunch of others over. Like, why don't you invite Einstein? Why don't you invite all these guys? Get all these guys over here. And a lot of them came. And then it's World War II, right? And von Neumann, because he's a math guy, he's really good at math. He starts to work for the ballistics people, the ballistics labs. And they're trying to figure out how to calculate the trajectory of a ballistic shell, cannon shell, as it travels through the stratosphere. Because now these things were going 10, 15 miles high, and they were going 40, 50 miles downrange. Oh, okay. Like, this is World War II, and the big ships on the big guns on the big ships, they could fire well over the horizon. How do you plan that? How do you plan that trajectory, right? Because these shells are going up into the stratosphere where there's different trajectory, different pressures, different temperatures, whole different regimes. And the only way to do that properly is to iterate. You've got to break it up into tiny little segments and walk your way through the atmosphere and then back down to calculate where they're going to be. So the computational load for modern warfare grew well outside the bounds of human beings. And, they tried to solve that by having armies of humans armed with desk calculators that could do add, subtract, and even multiply and divide. But you'd still need too many of them. And then they got the IBM card machines, these card readers, really early card stuff that you could program to do a simple addition. It would read a field from a card. It would do an addition. It would punch the result on another card. And then you could move these batches of cards from machine to machine to machine to machine as they went through very detailed calculations. And von Neumann was at the heart of that. And he was trying to do these trajectory computation. He was also trying to do blast computations. What is the best altitude to explode a high explosive at? And it's not on the ground, and it's not too high in the air. You've got to find the best place for the maximum destruction. So he was doing all of those calculations, right? And then he gets this phone call. Von Neumann's over in England at one point, and the war is raging already. And he's looking at all the fancy little machines they've got over there. NCR had a cute little machine that could add and subtract and stuff like that. And he's over there, and he gets this phone call, and he says, you know what? We need you back here. And the phone call is from J. Robert Oppenheimer. Nobody knows what's going on at that point, but we need you over here. Von Neumann was the only scientist, the only human, as far as I'm aware, who had the right to enter and leave the Manhattan Project at will. He could come, he could go. Nobody else had that privilege. I'm not even sure Oppenheimer had that privilege. But von Neumann did, because he had to keep working for the ballistics people, and he needed to work on the Manhattan Project to help them calculate the implosion characteristics of a plutonium core. One of the guys who was working with him, a young man at the time, was Richard Feynman, working on those card machines, moving cards around. They had those card machines running 24/7, week after week after week, just to do the calculations in the crudest possible way. And von Neumann was at the heart of it. And von Neumann's looking at this going, this is not sustainable. We're not going to be able to design these weapons with punch card machines. And he went on an exploratory tour. Where can I find the machine that will help me? And he saw Howard Aiken's Mark I, big machine that was an awful lot like Babbage's analytical engine. And he saw the ENIAC, which is a great big electronic machine. And none of those worked. None of those would have been good enough. And he conceived, with the help of the guys who designed the ENIAC, he conceived of the idea that data memory and program memory need to be the same memory, because that's the only way you can get speed. You have to have high-speed program memory to cycle the instructions quickly, and you have to have high-speed data memory to get the data in and out fast, and you can't ever sacrifice one for the other. And that was the great insight that led to the von Neumann architecture, which we all use today.
As I was reading this section in the book, I was cracking up because the last sort of phrase you do when you're talking about this was saying the program had to be data. And I was like, oh, okay, Mr. Closure. Like, yeah. Oh, okay, yeah. You're letting your internal biases leak here, okay? I see right through you on this one. Oh, I was laughing at that. Although I get it. Yes, he was right about that. But, maybe Lisp took it too far,
Something that kind of took, I guess the part that I remember the most clear was, I guess I didn't think about the consequences of these machines, in the sense that people had to work 24 hours a day on these machines, either debugging or attempting to get them to work. There was no indirect access to memory. It was like the thing you always worked on. There's no such thing as a pointer, any of that. But the part that kind of blew my mind is that the rooms in which they worked in were over 100 degrees Fahrenheit, whatever that is in fake land. I forget what it's called. Celsius. I'm gonna get some angry comments. That was just me fishing for comments, really. But it was extremely hot in those rooms, and people would be in there for hours, like as a sweat box, just like trying to make these things work to actually have this be successful. That is just mind-boggling to me that it was that hot.
That was actually the UNIVAC.
Was that the UNIVAC? I thought that was the Mark I.
The Mark I was a great big machine too, but the UNIVAC ones, when they built the UNIVAC had memory, and the memory was columns of mercury that carried sound waves. But the mercury had to be kept at 40 degrees C in order to get the right speed of sound. So they had heaters in those mercury tanks that would heat them up to 110 degrees Fahrenheit, 40 degrees C, something like that. And of course, they radiated like crazy. So the room would get hot. They didn't have air conditioning. So they're working in this room with these hot tanks of mercury, no air conditioning, and they're trying to debug these machines. They're trying to wire up these machines and debug them. And they wound up wearing nothing but shorts and went shirtless and doused themselves with buckets of water just to keep working in that environment.
My chair's not ergonomic enough.
That was actually my first thought, was like, they don't even have a keyboard or a chair. Like, those two weren't even things yet. Okay, sorry, I jumped a little ahead in the story. Okay, it was the UNIVAC that did that. Okay. My bad.
Yeah.
Sorry.
Yeah,
it was very exciting. It was a very exciting moment, just to think that, just trying to relate. I have no relation to this part of the story in some sense. Like, I don't think the last time I thought about the reliability of memory of any kind. Like, I don't think I've ever thought of RAM being unreliable. It's just not a facet of my thought process, let alone the ability not to have a pointer, let alone the ability to work in a room my room is nicely temperature controlled, and it feels good. I'm wearing a hoodie because it's not 100+ degrees in this room. And so, like, that whole notion, this stuff they had to work with, was just mind-boggling comparatively to what we had.
The viability of memory, the accuracy of memory was a problem. It actually still is a problem. It's just that we've solved it so well that nobody thinks about it. But in the early days, it was a huge problem because the dropout of a bit was significant. It was not uncommon for a bit to just not be there. And when you're running a program, you can't have the bits drop out. So there had to be a way to recover, and they invented all kinds of schemes, parity schemes. In the early days of core memory, every byte had an extra core, the 9th bit, which was the parity bit. Some of them had 2 extra cores so that you could recompute in case one of them dropped out. There was a lot of that stuff going on, especially and in the early days of dynamic RAM. There was a lot of that stuff going on. Probably still is, but it's buried so much now that we don't even think about it.
So I think it's
I know Prime skipped ahead. Oh, go ahead.
Yeah,
Prime,
I was about to say, sorry. Since I skipped ahead, sorry, TJ,
Okay.
took that one right from you. But I think we're going to probably enter into the figures that I think most people probably have at least minimally heard of, and that they're very, very familiar with. Would you mind, because this is like a huge historical figure, at least during my college and all that, would you mind kind of giving like a brief introduction to the next character in this little character walk we're doing, Alan Turing?
Alan Turing, what an interesting fella he was. All right, so the one thing everybody knows about Alan Turing is that he was gay. Let's get that out of the way right away. He was a brilliant young man, very smart, and yet in only very narrow ways. He was mathematically oriented. He liked maps. He liked recipes. He liked chemistry. But any other topic, and he just wasn't there. Couldn't deal with it. He was nearly expelled from school because he wouldn't deal with social issues or anything outside of the very narrow focus. If he was interested in it, he was deep. He went really deep. So fascinating guy, eventually manages to become a significant mathematician. And there was this problem that mathematicians were working on at the time. David Hilbert, the great German mathematician, had posed these problems. And the problems were about mathematics itself. Is mathematics consistent? Is it decidable? All these really interesting, deep questions. And Kurt Gödel blew him out of the water pretty early on. Mathematics is neither complete nor consistent, as Gödel proved. And then it was Turing who came along, and Turing proved the last of these, which was the decidability problem. You can't even decide if a mathematical problem is solvable or not. There's no algorithm that you can run to prove this. And the way Turing set about to prove that was by inventing a machine. We call them nowadays Turing machines, but it was just a thought exercise machine. You imagine a machine with an infinite tape, and it's got a single window. You can move the tape left or right, one cell at a time. In this window, you can read a symbol or write a symbol, doesn't matter, and the operator is a human being. And the human being does all of the operations according to a very simple script, which in our parlance is just a finite state machine. If the symbol is this, then do that. It's very, very simple. And using that machine, it's the most remarkable paper to read. If you've never read Turing's 1936 paper, on computable numbers, it is just a remarkable paper to read, because the man starts with that very basic idea and then invents assembly language and macros and everything, so that in the end he can prove that there are certain problems that have no algorithmic solution, proving that Hilbert's last question was no. Mathematics is not even decidable. It was in the pursuit of Hilbert's 3 questions that modern computing was born. And Hilbert saw all of his goals defeated. And yet in that defeat came our modern industry of computation. Just fascinating. Turing goes on, he writes that paper. It's a great big paper. Von Neumann reads the paper. Ooh, that's really cool. He invites Turing to Princeton. They couple up for a while. Then Turing goes back to England and gets involved with code breaking. And it's all of this computational ability that allows him to participate so potently in code breaking. But he's not satisfied. He wants Babbage's analytical engine. He doesn't say that outright, but that's clearly what he wants. He wants a machine like that, and participates in the design and the programming of the first 1 or 2 such machines ever to be built. Like his life goes on, and there's of course the whole gay thing where the government persecutes him for being gay, and they use chemical castration, which doesn't really work on him. He just goes to Europe, and then in the end they find him dead in his bed with a partially eaten apple next to him, and he's been very clearly poisoned by cyanide. And the rap is that he committed. But his mother says, no way. He did not commit. He was working with gold. He was at gold plating exercises, and cyanide is one of the chemicals you use in that process. And she believes that he, in a moment of carelessness, got a little cyanide on that apple. And when he ate the apple, he started to recognize the symptoms. And he knew there was no hope, so he lay down in the bed. And that's his mother's view. I actually adopt that view. I don't think Alan Turing was going to think about himself in any sense. He had a lot to live for. He was on the cusp of some great stuff. So I think his mother's view is the better view.
I had not heard that alternate proposal for it, which is like both options are very sad. You know what I mean? Like it's very sad either way. But yeah, I hadn't heard that one.
In the one case, you could at least say, the man died doing what he loved. And okay, and you can imagine being, somebody that smart, and all of a sudden you're starting to get symptoms, and you look at the apple, and you think, oh, damn it.
Yep.
Come on. What was I thinking? And then, okay, well, I know what's going to happen next. Might as well lie down and make myself comfortable. Not much I can do about it.
It definitely changes a lot. I mean, I've never heard this either until this moment. I can't believe you're just now sprinkling this on me. I don't remember that in the book. This is mind blowing right now, but it changes so much about it, because it's like it almost in some sense like feels way more sad. It wasn't even a self choice. It was just, it sounds like an accident. Like there's a whole world that exists in which he could have continued to produce amazing things that we just miss out on by sheer oopsie daisy. It sounds like.
Well, that would be my preferred view. I think I probably gave you guys a draft. Somewhat early.
I copied
it. Some of this stuff got in later.
Okay, that explains why we're both flabbergasted right now.
Yeah, that was news to me. I didn't catch that in the draft that we had gotten for it. But one of the characters you had mentioned that I thought was very funny was Hilbert, and the quote from him that I thought was hilarious. Right, is that he's talking to Einstein, and he's trying to convince Einstein that it's so important that we figure out all this lofty math things. And Einstein just says this is so trivial. Why do we even care? Why are you worried? And Hilbert replies, if mathematical thinking is defective, where are we to find truth and certitude? And it like cracked me up because it just reminds me of programmers arguing about stuff online right now. Like, if Rust's safety is defective, where can we find like something's never changed? Like, they're just still angry, sending each other letters on the internet. Just now it's over Twitter. No, my truth and certitude.
Yes, there was the recent Rust memory leak. I forget which Linux component, and people are just like, "It's over. Rust
It's
leaked
over.
memory. We screwed it all up.
There's no truth in life.
Where's your God now, Linux?"
And Einstein's like, "Oh, come on, get over yourselves."
Yeah, that's what I picture is like Einstein quote tweeting the situation, and he's like, "Guys, this is so trivial. Why are we even worried about it?" Right? Like, they're all fighting, and Einstein's
Empirically, it doesn't even matter, right? Let's move on. That's so funny.
Oh, man. So,
If only historical figures could tweet, I think the world would have been a very hilarious place.
Bob, there's a book idea for you: reimagining historical disputes as tweet storms. That's what I want to see.
That's a good blog post, minimally.
I want to see Hilbert arguing with them over tweets, and suddenly someone's got a twit longer out. And I'd like to apologize for what I said last month. Turing, John Van or wait, who was Hilbert's like main acolyte? Was it Turing?
It's von Neumann, wasn't it?
Von Neumann, right?
Yeah.
Von Neumann replying like, "I'm sorry, I wasn't familiar with your game," like the Shaq meme, and he leaves Hilbert after. Oh man, that would be a good one.
TJ has a whole startup going on in his head right
now.
now.
No, I'm thinking I need to go make a bunch of YouTube videos with this that only 7 people will laugh at because they're really inside baseball.
All right.
We think everything's different now.
Yeah, but it's the same.
Different now.
It's the same. Yeah.
They were doing just exactly that stuff.
Yeah. The next character, though, that I did want us to talk about, and I thought this was a really interesting framing, was Grace Hopper. And in your book, you said that she was the first software engineer. I'd love to hear where you're coming from on that angle, because I really appreciated it in the book. And I know Twitter's going to be mad because we're saying engineer, but I think it actually applies to her. Like, we're not engineers, but she was.
Yeah.
Yeah.
She was certified. There were certifications with her. I got none of that.
Grace Hopper, fascinating character. Mathematics teacher, one of the first females to graduate Harvard or something like that with a math degree. She taught at Vassar for a long time. She's in her mid to late 30s, married to a man. I guess it wasn't a very satisfactory marriage. Pearl Harbor happens, and she says, "I'm joining the Navy. Let's get divorced. I'm joining the Navy." So they get divorced, and she joins the Navy. She figures she's going to be sent to a cryptography unit because she's a mathematician. So she gets her, she goes through boot, she goes through officer training, comes out as a lieutenant, JG, whatever that is in the Navy, and then is appointed to Howard Aiken. Now, Howard Aiken is this guy who dreamed up of a computer and thought, "Wow, we should make a computer, an electromechanical machine, right? So it should be able to add and subtract, multiply, divide. It should have memory. We should be able to move things around, and it should follow instructions from paper tape." That was kind of the limit of his contribution. But he convinced IBM to build the damn thing, actually to design and build the damn thing, which they did. The Harvard Mark I, a locomotive-sized machine with a great big electric motor that spun at 400 RPM, that drove all the gears and the levers, that did all the adding and subtracting and the memorizing of data. And the thing was programmed with paper tape, which the programmers had to punch one hole at a time. When you were writing code, you wrote your code on paper, and it was code, right? In code, in the sense that it was just raw numbers. And then you would take that sheet of paper and you would push individual buttons on a tape punch to punch the holes that would drive this machine. And Hopper gets in there. There's 2 other guys that know how to work the machine. And Aiken is not one of them. Aiken is off in his office. He's the captain of the ship. He's not going to let anybody bother him. They just have to get the work done. These two other guys, and she joins as Aiken's right-hand man, second in command, first officer of the ship, if you wish. She's got to learn how to operate this machine. She knows nothing about it. She knows nothing about computation in general. Aiken says, I want you to calculate the interpolation coefficients for arctangents, and you've got a week. Just 23 digits accuracy. You got a week. And by the way, the machine is busy, so don't bother the programmers. And maybe we can sneak some time on it, but you're not going to get a lot of time. Which she pulls off. She pulls it off and begins to learn how to get real things done on this cantankerous, behemoth, loud machine that's impossibly slow from our standards, but the fastest calculator alive at the time. And she begins to learn how to do it. And she, with her two companions, work out the disciplines for writing code, for notating, for common code, for punching accurately, for saving routines that they could reuse over and over. They called them subroutines. They began to put together what you and I would consider the most primitive parts of a programming discipline, but there was none then. And she was the one who was instrumental in that. She wrote the first programming manual ever. She taught the first programming course ever. She invented terms. She came up with a glossary of terms that we use now without even thinking about it. Terms like address and pointer and debug, and terms that we now just kind of toss around. Byte, bit, all of these things she wrote down. She drove the community. As the programming community grew, she was the one driving it. She came up with the first user groups. She came up with the first computer conferences. She was there at the heart of it all. And in the midst of all this, the machines were getting better and better. At first, her first one was electromechanical. You couldn't even do a loop. I mean, you could put the tape in a loop, a physical loop, but there were no jump instructions. There were no if instructions, right? So, they did actually do that. Tapes in loops sometimes, but usually not. Usually they wrote instructions to the operators about how to reposition the tape if the registers are this, otherwise position it over here if the registers are that. So the if statements and the loops were actually executed by the operators at 3 a.m, as they shunted through the computations. But later on, she got involved with the electronic machines. She was deeply involved at UNIVAC and started really programming. The UNIVAC machines were von Neumann architecture machines, right? They had memory. The data and the programs were stored in memory. She was writing in the assembly language at the time. That was actually the machine language at the time. The machine language was not numeric. It was alphanumeric. And so the instructions were kind of mnemonic, sort of. She got involved with that. She began to realize, this would be like 1950. She began to realize that the bottleneck in computation was going to be finding enough programmers. That had not been the problem early, but it was starting to become a problem. We needed to find more programmers, and most programmers weren't going to tolerate the primitive conditions that she had begun to enjoy.
So she recognized the sushi dinners were super important, is what you're trying to say. Like right away, she saw it.
So ping pong tables everywhere. Is that the solution?
Yeah, that's right. Yeah. We need play areas for the kids. Yeah, all of that stuff. No, she was really focused on the languages. She said there must be a better way to phrase these languages. There must be a simpler way. It's not quite as complicated. And she came up with a number of different levels. And with each level, they got more and more advanced. Now, she wasn't the only one working on this. Other people were working on languages too. But she was the most dedicated, the most disciplined. She had thought through the issues more than most people had. So in the end, she came up with this idea for the language to own all other languages, and in the darkness bind them, and came up with probably the worst language ever conceived, which was COBOL. Her concept was glorious. Let's use English. Let's use English as our language. Why can't we use English as our language? And then everyone will understand it, which did not work.
So question, did it not work because there's a lot of things that become popular because they become popular. Like there's the whole phrase like C++ is largely popular because Bjarne was just like so forceful with its popularity that he helped kind of like make it popular by his own willpower. Was her language, because it's hard for me to say her language was bad because I never have programmed a computer back in those days, so it had to be a great leap forward comparatively to its counterparts at that time period, but at the same time, other languages were coming. Why was COBOL not like successful? Is it purely just championing? What is it?
It was certainly a great leap forward. There's no doubt about that. Nobody had ever put together a compiler of that complexity. And then it was competing with Fortran at the time, but very, very impressive kind of language. The problem with the language was the motive for creating it in the first place. She believed that business would not be interested in computation if business did not understand the programs. And business used English. And she was adamant about this. She actually at one point threatened to walk off the committee and never talk to anybody again if they did not adopt English as the language. She was determined about this. Other people wanted to see mathematical formulas, sort of like Fortran, like we use today in Java and C and C++ and languages like that. But she would have none of it. We're not going to use mathematical formula, right? We are going to use English. Multiply A by B, giving C rounded, period.
That's how I've always wished I could write programs that way. That just sounds so much more fun.
Yeah, oh yeah, me too, yeah. And I did. I wrote some COBOL, and fortunately my brain survived, but it was a harrowing experience. It's so inefficient, and the data model is just so bad. And then you've got to write these English statements, and they're so wordy. So you can tell that I like the language a lot. I think it was a great mistake to build the language that way, but they did, and the language was wildly successful, and we still have COBOL programs running today. Can't fault it for that.
Is it successful? Because if I remember correctly, very integrated with IBM, and IBM kind of really integrated with all the banks. And then the banks were all trapped on COBOL, and then no one can translate it. It's like, we're forever here because that's ATMs, and that's just what we'll live on for the rest of our lives.
It was not just IBM. Back in those days, there were a lot of companies that were making computers. So there was GE, there was NCR, there was IBM, there was Univac, and they all had languages that were kind of similar to COBOL, and in fact, COBOL took from a lot of those languages and integrated it. So they were all ready to accept it. So COBOL went in a lot of different directions. It wasn't just IBM. Now, if you add a few years to that, IBM dominates. But at the time COBOL came out, IBM was a significant player, but it wasn't clear that they were going to be the dominant one.
Awesome. Well, this is where I wanted to stop for this episode, and people have to read the book if they want to know about more of the history, or maybe we can have you back on and we can cover the next era of computing, like a little bit later in Grace Hopper's career, and as a few other people sort of show up on the scene. So we're going to transition into our Q&A section.
So can we take a quick pause there? Could you kind of like elaborate to everybody things we didn't even talk, like don't elaborate in any sort of detail, but things we didn't even talk about that we didn't even cover during this time period, because there's quite a bit more. We just kind of really glossed over that.
Oh my, we did not talk at all about Dennis Ritchie, Ken Thompson, the inventions of Unix and C. What a story that is! Jiminy Christmas! You would expect, something like C would have been invented by serious people. These guys invented C so that they could play Space War. It's just a tremendously funny story. And, they changed the world. They changed these guys just to play Space War. They changed the world. Wonderful, wonderful story. We did not talk about John Bacchus, the inventor of Fortran. What an interesting character, John Bacchus. Complete ne'er-do-well. Did not have any interest in success or life or anything. He just wanted to party and have a good time. And magically he becomes the most consummate project leader to date for that time, right? Just remarkable. So yeah, there's a lot of stories that we did not tell in this session, but they're in there and they're fun.
Very much so. It was such a good read. I absolutely loved it. Okay, now we can go to the Q&A part. Okay, flip to the Q&A.
Well, yeah, but I also have a question. I have moderator's prerogative here. So one of the movies you reference in the book is The Forbin Project, which is a ridiculously good and underrated movie, in my opinion, not very well known. What's your favorite programmer or like computer movie?
Ooh, my favorite computer movie has to be 2001.
Nice.
HAL 9000. There's ChatGPT for you. I mean, take a look at the way that computer moves through that script. And other than the self-motivated part, HAL was self-motivated. But other than that, you could see ChatGPT doing just about all that stuff. All these large language models and big learning machines, they could easily have been doing a lot of that work. So that's really interesting to me. I think of all of the movies about computers, that one is the most accurate as far as looking into the future. Got the dates wrong, but other than that, a HAL 9000 kind of device seems to me to be feasible.
Yeah. I mean, that's what like 01 and really is just giving it more power to keep on running itself. You just kind of like let a while loop happen around ChatGPT and you can get yourself into a HAL 9000 situation.
Yeah, I'm not convinced it's as simple as that. Self-motivation is a complicated problem to understand, right?
Well,
how do you come up with a machine that queries itself meaningfully? It's pretty interesting. But another one of the movies that I liked an awful lot from a computer point of view was Jurassic Park, because that was real, except for the one moment where she says, "I know this. This is a Unix system," but everything else was great. Dennis Nedry was a terrific character. It was just wonderful. And the other guy, right? I hate this hacker shit.
I mean, we still get the meme today. Look at this guy. Look at this. Look at this guy. He uses Vim. Nobody cares. See? Still love that. All right. Let me start pulling some questions because I think one of the first ones right out the gate is actually pretty good. So he says, considering the journey from Ada to AI, if you look 15 years ahead, what path do you think software programming will take? Do we think we will have more frameworks and large software systems built entirely by AI, or will the user wants factor remain beyond AI's reach?
The user wants features will remain well outside of AI's reach because they remain well outside of most programmers' reach as well. It's very difficult to build a system that a user wants because you have to decide, what to ignore that the user said and how better to address the user's needs. And we don't have large language models that can get anywhere near that. The human will be involved in writing code for the foreseeable future, as far as I'm concerned. It'll get easier. We'll get these things will be a good assistance. They're already kind of fair assistants, sort of, sometimes. But I think they will get better. They would become good assistants. You could give them a task and say, "Hey, write this up for me," and then you'd better check it because they'll get it wrong. So you could think of them as a college student or something like that. But I think that will be a growth in utilitarianism, but not a growth in insight or creativity or human ingenuity. I don't think that's coming anytime soon.
We're going to get closer to Grace Hopper's future, right? more programming with English, maybe, at least for some small parts of your system.
COBOL was
So,
right.
yeah, I mean, yeah, the query language will probably shift more towards English, although my suspicion is that it will formalize. Now it will become a formal query language, much like lawyers use. That certain words have certain meanings and certain phrases have to be used in certain ways, and we will wind up with programs that read like legal documents, and will be just as impenetrable to the layman.
That actually sounds like the worst possible future. Thank you for making me actually hate my life.
I changed my mind. I want the AI to take my job. Okay, I've got one. I like this one a lot. So did switching over to functional programming with Clojure change or soften any of your views on things like solid principles or test-driven development?
Oh, no, not at all. And even the idea that it was a switch over isn't quite right. I didn't switch over to Clojure. I just started using Clojure. Was there a fundamental shift in the way I thought? No, there was a minor shift because I had not been used to immutable variables, and that was kind of interesting for me to get my hands around. And it's not quite fair to say that I wasn't used to it because I had used other languages, but this was a more significant shift. But that's just a small thing in the panoply of software. Holy cow, most of the stuff I do in Clojure, I used to do in Java, I used to do it in C++, I used to do it in C. Most of software remains the same. Just, okay, it's a little more convenient in Clojure. And that's really, really all it comes down to. Do I still do test-driven development? Yes. Do I still use the design principles? Absolutely. Do I still use design patterns? Yes, I do. In fact, I wrote a book about that topic called Functional Design.
Okay, this one's not meant to make you feel old. But what was it like growing up at that time period? Was the attitude similar to how people see AI nowadays? I'm not exactly sure which time period she's saying, but I assume it just means the ever-increasing amount of languages and expertise kind of falling away. I think, what is it called? It's something like real men don't eat quiche. There's that whole topic about real programmers don't eat quiche. And it was just like, we use spinning drum memory because we can program it the most efficiently and all of that.
I saw my very first computer at age 12. It was a plastic machine. It had 3 flip-flops, 6 AND gates. You could do 3-bit problems with it. And it was just a little plastic thing that I could hold in my hands and manipulate. And I completely fell in love. Not just with that little machine, but with the concept of the machine. And it's very much that at that point, I made the career decision of my life. I knew what I wanted to be. I could see the possibilities well beyond that 3-bit little machine. And I started getting into electronics. I built some stuff out of electronics. I put together machines that could add and subtract, multiply, divide in electronics. Back in those days, it was pretty easy because we had begun to get integrated circuits. So wiring things together wasn't too hard. I got my father would take me and my buddy to the digital equipment sales office, which was about 30 miles away. And those guys let us play on their PDP-8s and PDP-10s. And we would go like every weekend. Summer, winter, didn't matter. We'd be doodling around on the PDP-8s and the PDP-10s in those offices, teaching ourselves assembly language, teaching ourselves binary, teaching all this stuff. I was absolutely committed to it. It was my life. I was going to do this, period. And the viewpoint at the time, just in general, was unlimited possibility. That wasn't just me. That was everybody involved in the industry. Unlimited possibility. We could see Moore's law. We could see that exponential growth. We were experiencing it in the small, but we could see where it was going. And that was an exponential curve that we all knew. We all knew we were going to ride that roller coaster to the top. So, and it was a hell of a ride. Back in those days, I don't know if you experienced this. You could get a computer. You had to get a new computer every year or every 2 years, right? Because the old one was so slow and so small that it just wouldn't run any of the new software. It was a wild wild time. I started out with machines that had 4K of core. And I thought that was a lot, right? And it was every year. Oh, 8K, 16K, 32K, a megabyte, 2 megabytes, 12 megabytes. The discs would have maybe a megabyte on them, maybe, depending on the disc, and they were great big things. And then, the discs get smaller, but they get bigger inside. All of a sudden, you've got 20 megabyte discs, and then 100 megabyte discs, and then a gigabyte. Oh my God, a gigabyte! I remember seeing my first gigabyte. Gigabyte. Those were very heady days.
I luckily got to grow up in some of that era. I remember installing Doom and Unreal Tournament and having to buy like graphics cards. And then when I went to I went from Unreal to Unreal Tournament, it's like I had to get a new computer to be able to run the next generation of games. And every computer I got was like 300 or 100 megahertz, 200, 400, 800. I just thought I was going to go, like, I was too young to know about Moore's Law. And I remember in high school, like, seeing the decline in like sophomore year, something like that, where it's like 1.6, and the next year was like 2.2. And I was like, hey, that's not as fast as it's been. And all of a sudden it was like 2.5, and it was like just kept on not going anywhere. I'm like, what the hell's happening here? What happened to what happened to this? I thought we're going forever.
Not going forever. Yeah, I mean, programmers today are going to live in a very different world than I lived. Right? They're going to live on the plateau. Now, it's a hell of a good plateau, but it is a plateau, and that takes a different mindset, I think.
So, sorry, some of the people in this chat are born in this century. Unfortunately, I can't relate. But so their question is, what's the most unhinged fact you found researching the book? I don't know if you use unhinged. It's just kind of like absurd.
The most absurd tale in the book, and I'm going to say it's absurd, and yet it's completely believable, was the path that Ken Thompson took to AT&T. Ken Thompson was a college student. That's all he ever wanted to be. Didn't want to graduate. Didn't want to leave school. He loved it at school. He knew he had command of the big computer room, and that was his. He was the operator. He was everything. Nobody touched the machine if he didn't say so, and he would use that as his toy computer at 3 a.m. He decided he was going to stay there forever. His professors eventually had to fill out the form so that he could go into graduate school, which he kind of reluctantly did. His professors had to call up AT&T and said, "You really need this guy." And the AT&T guy comes out, and Thompson doesn't want to talk to him. Just blows him off a couple of times. On the third time, the AT&T guy says, "I'd really like to talk to you." And Thompson feeds him, Fig Newtons and apple cider or something like that. Something ridiculous. And the guy says, "We're going to pay your way out to Bell Labs." He said, "I don't want to go." "Well, come on, we'll pay your way out." And Thompson says, "Well, I do have some friends I could visit out there." "Well, yeah, visit your friends and come out to Bell Labs." He says, "Yeah, but I'm not taking a job. Not taking a job." And he goes out to Bell Labs, and he's very impressed with some of the names he sees on the cubicles. Oh, he knew some of those names, but he went to visit his friends anyway. And the offer letter followed him to his friends on the East Coast, and he got the offer letter, and he opened it up and said, maybe I'll take the job. It's completely ridiculous. So if you want to talk about unhinged, there's a guy, and that particular story is just one of many, where you think, okay, that's the guy that changed the world? Okay.
That's actually pretty fair. It's shocking that he literally changed the world in the sense that C is now the most mainstay language of potentially all time, and we're sitting there, he couldn't even get out of college. Man, I could relate to this guy so much, except for the whole success part. When I was reading it, I'm going to join in on this one. I can't remember who it was, so you're going to have to refresh my memory. But there was a beard club to identify if you were or were not working on a specific project, because IBM, I believe, did not allow beards. And there was the beard cult. And I was just like, this is the strangest story I have ever heard. That there was...
That was Dykstra.
That's right, dude. That was so good. Don't give any details away. It was so good because it was just too good. All right, TJ, pick another one.
So this one's from Code Girl. Thanks, Code Girl. After seeing so much evolution in computers, does it feel ridiculous what computers are now? Do you have the same fascination now as you did when you were younger?
I am in absolute awe of these machines. Here we are. I'm talking on one. Well, it's not one. It's like 80. But okay, fine. I am using this machine, and it is doing things that I could only imagine in my wildest dreams 30 years ago. Right, here we are. And okay, we've got some problems. It drops out from time to time because the internet was never designed to do anything like this, of course. But I'm in absolute awe. These machines are miracles. And even the fact that we're on the plateau now, right? And the machines aren't actually getting, better by a factor of 2 every year or so. They're still miracles. And look at our society. We carry these things around with us. We've got phones. We got AirPods. The AirPods have more computer power than the NASA had when we went to the moon. Right? I mean, the ability to compute is just so incredible that we throw it away. We just burn it in crazy conflagrations. We program in languages like Clojure, which are 30 times less efficient than C. But who cares? We've got the cycles to burn. It's a remarkable time right now, and I am in awe of all of these machines. I hope that awe continues.
Yeah, I have 3 little kids, and I always think about how my kids expect to be able to talk to any screen and have it do something, right? They expect that if they say pause, something will pause. You know what I mean? Because they hear me say pause the music, right? And it pauses, right? Or they've never had a world where the computers can't speak back to them and respond and do something in plain English, and that it just magically works. My kids don't think about Wi-Fi. They're 4, 4 to a newborn. Okay, so they're not thinking about Wi-Fi anyways. But I'm saying, they're not thinking oh, it's cool that I don't have to plug this into the wall and listen to that's me. I'm thinking of dial-up, and then my kids, yeah, it's just crazy to think their expectation is all computers talk and understand my words and do something, which is wild.
I still think about this thing all the time, which is that I used to play this online game that had a 30 megabyte client that I had to download. And this would take an enormous amount of time. And to this day, every single time I see a download bar, I still think back to that 30 megabyte download bar going, this is I'm watching that game download every second. And it's just how is this not the greatest thing in the universe? I still get all pumped up by download speeds, which is just, it feels trivial and ridiculous, but to me, that's just the coolest thing in the universe. I feel so grateful for it. I don't know.
We live in an age of miracles. And the best emotion you can feel about that is gratitude.
Mm-hmm.
Speaking of gratitude, what I feel there's a lot of just angst, especially around the job market, especially as a junior engineer. What are some words or something that you could help kind of bolster them up? Because obviously you are on one side of your career, they're on one side of their career, and theirs maybe feels less tenuous or less achievable than perhaps your side did. Maybe I don't even know if that's true or not. But what can you kind of tell them to pave the way for the next 20 years, shall we say?
Yeah, one thing is COVID kind of threw a big bolus into the job market, so we're trying to get over that, and I think we will very quickly. The demand for programmers is very likely to continue to skyrocket for at least the next 10 years. I think we double the programming staff in the world every 5 years, so we can probably continue to do that for a while. I don't think we're going to have a problem with employment. If you're a programmer and you want to become a better programmer, you need to read a lot. You need to try things a lot. You need to experiment a lot. You need to play a lot. Think of yourself like Ken Thompson, right? You're going to play Space War, and that's going to lead to Unix and C. Right? So play a lot, get into it, enjoy the hell out of yourself. Don't get fixed in one spot. And I don't mean by that an employer. I mean by a language or a system kind. Spread yourself around a little bit. Learn a little bit about financial systems. Learn a little bit about robotic systems. Learn a little bit about real-time systems. There's a lot of really fun stuff to learn in that environment. And the more you learn of different environments, the more general you become. The more you see the relationships between them and the differences between them, and the more you can cross-pollinate. So that's very important. Also, learn more than one language. Learn a lot of languages. Make sure there are different kinds of languages. Java's fine if you're a Java programmer. Maybe you're using Rust, or maybe you're using Go. Who cares? But then find some language that's completely different, right? Like learn Forth. Learn Forth. What a really interesting language that is. Learn Prolog. Nobody uses Prolog anymore, but learn it anyway. It's really interesting language. And if you've never programmed in C, you should program in C just a little bit, just to get to your roots. Just to get to your roots. If you've never done any assembly language, you should probably spend an afternoon doing some assembly language, and then pray to God you never have to do it again. It's pretty primitive. Do all these things. Read. Learn how to write. And I don't mean write code. Learn how to write your language, English or whatever it is. Learn how to communicate, right? Learn how to organize your thoughts into a nice deliverable that you can hand to other people, and they can go, oh, I see what you're saying. That will help you a great deal with your career. And learn how to teach, because in the end, the best way to learn is to teach. You will learn faster and harder than you've ever learned anything in your life if you find yourself having to teach it. So there's a whole bunch of advice I could throw out on the table.
That's really good.
Yeah, I love it.
I would say that was all W's in the chat.
Yeah, those are very similar to a lot of the things we like telling people. I think there's like a big fear for some reason that like you might spend a weekend on something and it's not like it doesn't go anywhere, or like it's not good. And it's just like, but that's okay. Plus, like, the alternative is probably like you're complaining to somebody on Reddit or something. Like, it's not like you're so optimized with your time anyways that you couldn't afford to waste it. Like, you're probably wasting it anyways. You might as well waste it trying something new. Like, who cares, And I think there is this like feeling like, ooh, I spent the weekend on the wrong language, and now my career's over.
It's very true. One of the biggest mentalities I see right now is that it's like if you're not on the whole modern web, whatever it is, and you're not constantly making some great modern web app, if you're not becoming the most specialized, most awesome, hyper, focused on this one technology, this is just taking Twitter, for example, then you're just falling behind. Like, in lieu of the fact that most programming isn't web. Like, web is just one slice of many different forms of programming, yet it's been like foisted on many young, new incoming programmers that this is the end all or the be all of programming. And it just causes this weird disproportional view that if I'm not progressing in this one narrow vertical, I therefore am failing, and I can see everybody else fall. This guy made Doom CAPTCHA, and I just failed at this thing, therefore I'm the worst programmer. It's just like, well, really? You learned. That's the big thing.
The web is going to go away.
Well, okay, that's like the biggest thing in the universe. Keep on going.
When it goes away. Okay, all right, yeah. So the web is going to go away, and when the web goes away, it will go away very fast, because something better will come along, and it will sweep through like a storm. So be ready for that storm. It's coming. Don't know when, but it's coming.
That's a very interesting perspective, because I guess for whatever reason, this is the same thing that happened to me in high school. It's the same thing that happened to me in several aspects of life. Is I look at certain moments or time periods as like eternal. Like, this is the end. This will be the thing that will always be around. But life already has taught me that has never been true. But I guess I've never thought about the web ever going away.
I'm gonna have to think about that one.
Yeah, you just ruined my day. Thanks, Uncle Bob.
Here, we'll pick a happy question. We'll pick a happy question instead. What is Uncle Bob's favorite aha moment he's had in programming? Like get up and have a happy dance level of aha happy moment.
Well, it was probably when I was 12. And that dumb little computer that I was talking about with 3 flip-flops and 6 AND gates, I could not figure out how that worked. It was magic to me. I could put the programming elements on it. I could cycle it. I could see the bits change. Didn't know how or why it worked. And I got the advanced programming manual, which they sent me for $1, I think. Took 6 weeks to get to my house. And I read through that. It taught me Boolean algebra, and it taught me basic stuff, De Morgan's theorem, and so on. And then I was able to write programs for this little machine. And that was a big aha moment for me, because all of a sudden I could see not just the inner workings of the machine, but I could see how to make bigger such machines and better such machines. And I began to understand what it would take and where this industry was going. So I guess that's the biggest aha moment for me.
Awesome. Well, unless you have another question, We'll probably wrap up. Okay, awesome.
This is our time to wrap up.
Yeah. Thanks, Bob, for coming on, and really appreciated. Maybe you can plug the book one more time. Tell people where the best place is to get it. We'll put a link in the description, too, for when people watch this later.
We Programmers. That's the title of the book, We Programmers. I wanted it to be We the Programmers, but the publisher thought that might be too political. So, We Programmers. And that's a little takeoff on Isaac Asimov, I, Robot. So, okay, kind of get that idea. And you can get it on Amazon, and you can probably a whole bunch of other places too. I don't know. I do know it's being delivered, so I've seen them out there. Although I don't have a copy myself yet. My publisher will probably get it for me soon.
And by we programmers, you don't mean OUI, right? Not like we programmers.
We
program programmers.
WE.
Awesome. Well, thanks, Bob. It's been a lot of fun, and we might have to have you back on, like I said, to discuss, more towards the later parts of the book too. Would be fun.
Sure, anytime.